Today, we're diving into something absolutely fundamental to psychometrics, item writing.
So here's what we're going to cover. We'll start by defining what item writing really is, both the art and the science of it. Then we'll get into that classic debate, essay versus objective questions. After that, we'll walk through the nitty-gritty rules for writing high-quality items, look at how we actually test those questions with data, and wrap up with why this whole painstaking process is so incredibly important for psychological measurement.
All right, let's kick things off with a central challenge in psychometrics. You see, at its heart, the whole goal is to take these hidden or latent constructs and make them measurable. We need to create things we can actually observe and quantify for traits we can't directly see.
I mean, really think about that for a second. How do you possibly build a valid scale for something abstract like intelligence or conscientiousness or even clinical anxiety? You can't just stick a ruler on it, right? The answer lies in developing a set of really carefully constructed prompts. The questions are tasks that we call items that get people to give us responses that point to that underlying trait.
And that brings us to the formal definition. Item writing is this super systematic process of creating and fine-tuning every single component of a test. Each item is like a single brick in the wall, and its quality, its psychometric properties, directly control how strong and reliable the entire test is going to be. Now, a really key idea here is that you don't just write the exact number of questions you need. Not at all. The goal is to start by creating a huge item pool or item bank. You want a surplus. And why? Because it lets you filter them empirically. You can use statistical analysis to cherry pick only the absolute best performing items for the final version of your test. Okay, so this leads us to a major decision you have to make when you're building a test. Not all items are built the same way. You've got to pick a format, and it's kind of like a fork in the road between two main paths, essay and objective items.
First up, we have what are called constructed response or essay items. These are your open-ended questions where the person has to generate their own answer from scratch. They're fantastic for assessing those higher-order thinking skills, things like synthesis, analysis, and evaluation. Think about scoring responses on projective tests. That's a classic example. And on the flip side, you've got the selected response or objective items. With these, the format is super constrained. The test taker is just choosing from a set of answers you've already provided. This is your multiple choice, your true-false, your Likert scales. The crucial part here is that scoring is black and white. There's no room for a scorer's judgment. And the trade-offs between these two are huge. Essay items, for all their depth, can really struggle with reliability. I mean, two different scorers can give wildly different grades to the exact same response. They also take forever to score, and you can only cover so much content in a test. Objective items pretty much solve all of that. Scoring is perfectly objective, you can cover a ton of material, and it's incredibly efficient. This is exactly why, as psychometricians like A.K. Singh point out, objective items have become the gold standard for most big psychological tests. Their structure is just perfectly suited for the heavy-duty statistical models we use, things like classical test theory and item response theory that you absolutely need to prove a test is reliable and valid. So, since objective items are so common, how do we actually build them well? It's not just guesswork, it's a process with some very clear rules. Let's dig into the actual blueprint for constructing a high-quality item. It really boils down to three foundational principles. First, clarity. The question has to be crystal clear and mean the same thing to everyone. Second, unidimensionality. This is a big one. Each item should only measure one single idea, period. And third, relevance. The item has to be directly tied to the specific thing you're trying to measure. Let's zoom in on that second rule for a second, the one about measuring only one idea. A really common mistake here is writing what's called a double-barreled question. It tries to ask two things at once. For example, imagine an item that says, "I often feel anxious and have trouble sleeping." That's a flawed question. Why? Because someone might feel anxious all the time but sleep like a baby. Their agree or disagree response would be totally impossible to interpret. Beyond those big three, there are other vital rules. You have to avoid any grammatical clues that might accidentally give away the right answer. You want to aim for questions that are moderately difficult, because that's the sweet spot for telling people apart. And for multiple choice, this is crucial. Every single wrong answer, every distractor, has to seem believable. A good distractor often represents a common mistake people make. Now, writing items that follow all these rules is really just step one. A well-written item is still just a hypothesis. To find out if it actually works, you have to test it with real data. This is where we move from the drawing board to the hard numbers.
This quality check usually happens in 2 stages. First, you do a preliminary tryout, which is basically a small pilot study. This is where you can find out if any of your questions are confusing or weirdly worded. After that comes the main event, a large-scale formal item analysis, where you give the questions to a big enough group to do some serious statistical evaluation.
So what are we looking for in that analysis? Well, we focus on a few key metrics. There's the item difficulty index, which is just the percentage of people who got it right. Then, and this is maybe more important, there's the item discrimination index. This tells us if the people who do well on the test overall are also the ones getting this specific item right. You want a high score here. Finally, you look at distractor effectiveness to make sure the wrong answers are actually tricking the people who don't know the material. Any item that bombs these tests gets either rewritten or more likely just tossed out.
So, you might be wondering, why go through all this trouble, this massive, multi-stage process? Well, the reason is simple. The quality of a test isn't something that just magically appears. It's a direct result of the quality of its individual parts. In a very real way, the items are the test.
And the payoff for all this hard work is huge. It's what gives the final test its integrity. Careful item writing leads to higher reliability, which means the test is consistent. More importantly, it leads to better validity, which means the test is actually measuring what it claims to measure. At the end of the day, it's what ensures our measurements are accurate, meaningful, and fair to everyone. And those are the absolute cornerstones of ethical psychology.
You know, we've all been there. You're taking a test, you read a question, and you just think, wow, that is a terrible question. But what if you could actually prove it with data? We're going to cover how to measure a question's difficulty, gauge its power to separate high performers from low performers.
So, here's our roadmap. We'll start with the big picture, the anatomy of a question. Then, we'll get into the nitty-gritty of measuring difficulty and discrimination. After that, we'll see how those two really need each other. And finally, we'll wrap it all up by talking about how to put this analysis into action.
All right, let's jump right in. At the end of the day, when we design an assessment, whether it's a final exam or a job certification, we're hoping our questions are good, but how do we actually know? How can we be sure we're not just guessing about the quality of our own work?
This right here is the fundamental challenge. Is this question really measuring what you think it's measuring? Is it fair? Is it doing its job? To answer that, we have to move beyond our own gut feelings and into the world of objective, hard data. And that's where item analysis comes into play. Think of it as putting each individual question, or item in psychometric speak, under a statistical microscope. The goal is super practical. Use the data from how people actually answered the test to decide what to keep, what to fix, and what to just throw out. So our first tool is probably the one that makes the most sense right off the bat. We need a way to figure out just how hard each question really is. This is our starting point for understanding how any item is performing. In the field, this is called item difficulty, and we use the letter P to represent it. It's literally just the percentage of people who got the question right. Sounds simple, doesn't it? Well, there's a funny little quirk in the language here that can trip you up if you're not careful. And here it is. You have to kind of flip your brain for this one. A high p-value means a high percentage of people got it right, which means the item was easy. And a low p-value means very few people got it right, which means the item was hard. So just burn this into your memory. High p means easy, low p means hard. It's totally counterintuitive, but it's absolutely crucial. Now, the good news is that calculating it is a piece of cake. Let's say you have 100 students and 60 of them got question 5 correct. You just divide 60 by 100. Boom, your p-value is 0.60. That's it. You now have a precise, objective number for how difficult that item was for that group. So, what p-value are we aiming for? Well, as A.K. Singh points out here, the real sweet spot is somewhere in the middle. Think about it. If a question is super easy or super hard, it doesn't really tell you much about the differences between students. And that brings us to that key word he uses, discrimination. We'll circle back to that in just a minute. And this isn't just a theoretical exercise. Understanding the difficulty of each item is what allows a test designer to do their job properly. You can balance the whole test, make sure the scores are actually reliable, and get a nice spread of results instead of having everyone just clumped together at the top or the bottom. Okay, so we've got difficulty. Now let's level up to our second metric, which is honestly even more powerful.
See, it's not enough for a question to just be medium difficulty. It also has to have the power to discriminate.
Item discrimination, or D, is all about a question's ability to sort people out. A really good discriminating question is one that the students who know their stuff get right, and the students who don't get wrong. It's like a finely tuned filter.
So, how do we get this number? Well, first, you rank everyone by their total score on the test. Then, you slice off a top group, let's say the top 27%, and a bottom group, the bottom 27%. For a single question, you calculate the p-value for the top group, and then you calculate it for the bottom group. Finally, you just subtract the bottom group's number from the top group's number. That result is your discrimination index, D. And what you do with that number is so clear. If you get a high positive D value, great, that's a good item. You keep it. If it's low or 0, the item isn't really doing anything useful, so you need to revise it. But if you get a negative value, that is a huge red flag. That means the low scores are actually getting it right more often than the high scores. Something is seriously wrong with that question, and it probably needs to be tossed out completely. And just like Singh says, this D value really tells you how useful an item is. If a question isn't helping you discriminate, it's basically just dead weight. It's not adding any valuable information to your assessment. So if you do find an item that's a poor discriminator, this is your troubleshooting guide. First thing to check, is the answer key just plain wrong? It happens. Or maybe the wording is confusing, or maybe the content just doesn't line up with what you were trying to teach. This helps you figure out what to fix. All right, now it's time to bring our two big ideas together. You can't just look at difficulty by itself, and you can't just look at discrimination by itself. The real magic happens when you look at them both at the same time. And here is the single most important takeaway. There is a direct relationship between these two things. The questions that are best at telling students apart are almost always the ones that have a medium level of difficulty. This chart just says it all, doesn't it? Look, if a question is super easy, everybody gets it right, so it can't discriminate. If it's super hard, everybody gets it wrong. Again, no discrimination. The maximum power to tell people apart is right there in that sweet spot in the middle. So let's wrap this all up. How do we take this cool analysis and turn it into real-world action? How do we actually build that smarter, fairer, more effective test we've been talking about? Ultimately, this whole process comes down to using P and D values together to make smart, data-driven decisions instead of just going with your gut. By looking at both numbers, you have a clear, objective reason to keep an item, revise it, or get rid of it. You're no longer guessing. You're engineering a better assessment based on evidence.
We're talking about the huge difference between norm-referenced and criterion-referenced testing. Understanding them is the key to figuring out what our scores actually mean.
So here's our game plan. First, we're going to tackle why a raw score on a test is, by itself, pretty much useless. Then we'll get into the statistical concept that breathes life into those scores, norms. From there, we'll explore the two big philosophies of measurement that grow out of that idea. And finally, we'll figure out how to choose the right yardstick for the right job.
All right, let's dive right in with a fundamental problem that haunts all kinds of measurement, whether it's a pop quiz or a high-stakes licensing exam. It's all about the problem of interpretation. I want you to imagine something. Someone takes an aptitude test, and they get a raw score of 120. So, what does that number really tell you? Is that good? Average? Does it mean they're a genius, or that they totally bombed it?
The real answer? On its own, that score of 120 tells you, well, absolutely nothing. It's just a number floating in a vacuum. It doesn't have any context, any scale, any anchor to reality. To make that number mean something, we have to compare it to something else.
And that right there brings us to the foundational solution, the thing that gives psychological testing its scientific muscle. To give that score any meaning at all, we have to talk about norms.
So norms might sound a bit academic, but the idea is actually pretty straightforward. Norms are our frame of reference. They're basically statistical snapshots of how a huge, representative group of people, we call them the norm group, did on the exact same test. By looking at their performance, we can figure out the average score, the spread of scores, the whole distribution. And suddenly, our lonely little raw score isn't lonely anymore. It has a home, a context.
This whole process is called standardization. And as the great psychometrician Anastasi points out, this is what lets us change a raw score like 120 into something much, much more useful, like a derived score. For instance, we could find out that 120 puts you in the 90th percentile. Now we're talking. That means you scored better than 90% of the people in that original group. See? The score is no longer just a number, it's now interpretable, and we can compare it.
And A-casing really drives this point home. This isn't just a nice-to-have feature, it's absolutely essential for a test to be scientifically valid. Without norms, we have no real basis for evaluating how people differ, and our interpretations are just, well, opinions. Norms are what provide the objective backbone for the entire enterprise of testing.
Okay, so we get it. Norms give us context, but how we use that context is where things split into two very different ways of thinking, two competing philosophies of measurement. It's the clash between relative and absolute standards. My favorite way to think about this is to imagine a marathon. A norm-referenced approach asks, what place did you finish in? Were you in the top 10%? It's all about how you stack up against everybody else. A criterion-referenced approach asks a totally different question. Did you finish in under 4 hours? It's not about the other runners, it's about whether you met a preset standard, a fixed criterion. And this table just lays out that division so clearly. Norm reference tests are all about ranking and spotting individual differences. The big question is, how do you compare? But here's the catch. Scoring in the 99th percentile doesn't actually tell you what specific skills you have, just that you have more of them than most people. On the other hand, criterion reference tests are about absolute competence. Did you master the material? Yes or no? The limitation there is you don't get a good sense of your relative standing. Two people can pass, but one might have a far, far deeper understanding than the other. And you see these norm reference tests all over the place, especially when the goal is to select or classify people. An IQ score is only meaningful because it places you on a bell curve relative to everyone else. The SAT is designed specifically to help colleges rank applicants against one another. The whole point is to tell people apart.
Then you have the criterion reference tests, which are all about certification. When you take your driver's license exam, the government doesn't care if you're the best driver in the state. They just need to know one thing. Have you met the minimum safety standard to be on the road? Same goes for a medical board exam or your final exam in a university course. It's about proving you've mastered a specific set of knowledge.
Now, up to this point, we've kind of treated these as two completely separate things. But in the real world, the line between them can get pretty blurry. So let's talk about how these ideas come together. And here's Anastasia again, with the perfect point. These two approaches are not mutually exclusive. In fact, they often influence each other in some really important ways. Think about it for a second. How does a teacher decide that a 70% is the passing grade for a test? Where does that criterion come from? Well, a lot of the time it's based on looking at how students have performed in the past, which is a normative idea. They're looking at what an average group can be expected to achieve to set a reasonable standard for mastery. That criterion isn't just plucked out of thin air. So if the line is blurry and these two ideas feed into each other, how in the world do we decide which one to use when we're designing a test? Well, it turns out it all comes down to one single overriding principle.
The answer is simple but crucial. It all depends on the purpose of your test. What question are you trying to answer? Your testing objective is the only thing that dictates which yardstick is the right one for the job. So, let's just boil it down to a simple decision. Do you need to rank people to find the top candidates from a big applicant pool? Then you need a norm reference test. But if you need to certify that a pilot knows how to land a plane safely, you need to measure their skill against a fixed standard. You need a criterion reference test. It's that simple. The purpose defines the tool.